Now that we have generated the pre-finishing and the finishing operation using parallel finishing, you will still notice that there are some sections of the model in the steep areas, there is still some scalloping being left. When you take a look at the part and the cut material simulation, you'll see this on these steep sections, you'll still notice scalloping being left. Now to be able to finish these sections, these steep sections, we have a 3-axis method called horizontal finishing, or also known as Z-level finishing. Now the Z-level finishing is great for finishing steep sections. For example, it could be like features like truncated cones when you have steep areas. So it'll basically step down in Z levels following the 3D model. So we'll go ahead and pick horizontal finishing. And again, if you do not pick any regions for containment, the toolpath will be generated based off the entire model. The most appropriate tools for horizontal finishing would also be like a radius tool, which could be a ball mill, or it could be a corner radius tool. So we'll go ahead and pick a 1/4-inch ball mill. We'll set feet and speeds, clearance to be automatic. In the cutting parameters, we would set the cut direction. It could be climb, conventional, or climb conventional. We'll come back to these parameters and revisit them in a moment. Cut levels, you could specify your cut level containment. You control the step downs. Also, you can specify if you want to go all the way down in the Z to the bottom edge of the part, or if you want to restrict the toolpath, I could say I want to restrict it right up to this level, or I could even, enter in a value in here saying that I only want to go up to a certain height, and then pick generate. Will result in the horizontal finishing toolpath. So you're noticing here the toolpath generator is known as horizontal, or also called Z-level finishing, where it's generated in constant Z levels. I'm stepping through the Z-level display, and as you can see, the toolpath display in levels. So this is a good technique to program steep areas in your 3D models, and this will go ahead and take care of cleaning up all of these scalloping that were left in the steeper sections on this particular core mold. Now I could go back in here to tighten up the step down under cut levels, generate the toolpath. It's a much tighter step down, Z-level finishing. Now we could also exclude some of these areas that were already finished using the parallel finishing by specifying cut level containment. So we can set the top containment, and I can lower it down. So I can choose where you want to begin the Z-level finishing or the horizontal finishing toolpath at. So it'll skip areas above this top cut level containment and only cut between the top containment and the bottom containment. So you don't have to go back and refinish areas that are already being finished using the previous parallel finishing operation. So selecting pause and simulate to end simulates the entire process. Now the cut direction in horizontal finishing by default is set to climb conventional, which means it alternates between climb and conventional between each cut level. So if you take a look at this toolpath here, the first level does a climb cut, the next level does a conventional cut, and then it alternates between climb and conventional. So if you'd like to just cut in one direction, you could go back and set this under the cut parameters to climb only, and then generate the toolpath. Like how we could fit arcs in other 3-axis toolpath methods, we can also perform arc fitting in horizontal finishing as well by specifying the arc fitting tolerance and generating the toolpath. The arc fitted to the toolpath appears in dark blue, and the turquoise color represents the linear motions.